Mais je tiens pas à rester en
On va chercher.
We should start.
Okay.
Okay. Because it's 9:50, right? Yeah, okay. Good afternoon. This is the roll meeting. Thank you for coming. So many people. Second sign network. Okay, please sign the blue sheets. Okay.
Hold on to them for a few minutes.
Yeah, sure. I will hold them.
No, hold on.
Thank you. Okay, we start, so we are on time. Please be aware that this meeting is aligned with the note well. I'm not going to read it, but you have to be aware of that. Well, we want to say thank you very much to Peter. We have a new co-chair. Peter has helped a lot. And now it's Dominic. Thank you. Thank you. Well, now welcome to Dominic. Thank you. Thank you. Thank you. Okay, this is the meeting materials. We need JavaScriber and minute taker. Who can help with the JavaScriber? Yeah. Okay, thank you very much. And minute takers, do we have? We have to wait a bit until more people arrive. Okay. Please volunteer for minute takers, and if you can add some information. Oh. Ah. Okay, thank you very much. Okay, it's fine. Thank you. Well, this is our agenda for today. We are going to meet today and tomorrow. So this is our agenda. Comments for the agenda? No? Okay. We have updated the milestones to be more aligned with their reality. So, yeah, you can see that some documents, most of all the documents were updated. So please review this, and if you want to send comments or suggestions, please let us know. So, yes.
Pascal Tuber here. I think for the DAO projection is still a bit optimistic. Next December, we are not there yet. I think it's going to be next year. Hopefully by the next IETF, if we really work hard on it.
Okay, thank you very much. We will update it. Hi, Miguel. Thank you. Okay, we have active internet draft. Most of them are going to be discussed today, or at least give some updates on changes. Um, and they are expired in internet draft that we should work on in the near future to be aligned with the milestones. And there are as well related internet draft that we're going to get discussion today and tomorrow, between today and tomorrow. Okay, we noticed that the GitHub repository is great to tracking issues. There is a lot of people updating and creating issues on GitHub, and that is great. This tool is more useful than the previous one. I mean, I see more people actively participating in the creating tickets in GitHub. But still, so we are going to track these GitHub issues and as well the all tracking system tickets. So we are going to watch both. But it seems that the community, the working group, prefer the GitHub because it's super easy. Right. Okay, some relation for draft. No. So we noticed that unaware leaf draft, it's aligned with use of Ripple info in terms of terminology. Then efficient MPDO relies on Ripple status in aware leaf. Then for capability mode of operation draft, we have kind of three relations. And for the projection, there was comments in the mailing list that we asked to the working group, should we use a new mode of operation for that or not? This is a question to answer to the working group. What do you think? No, but yeah, because he's going to, we can answer. Then for turn on 8138, should be this implemented into capabilities? We're going to discuss this tomorrow. And then as well for tomorrow, eliding DIO information, synchronize the counter of capability draft. So this is the relations that we saw in those current drafts. So as well, the DIO information draft could be aligned with this modification draft. We can see if maybe it can be merged. We have to discuss that. So this is the agenda for today. So we're going to start for Ripple observations. Raul is going to state the observation of which issues are still open in Ripple, some of them. Then Pascal gave us the update in DAO projections and which is the next steps to follow. And then we are going to talk about capability and mode of operation draft. And then we have wrap up on open floor. Okay, thank you very much. Raul, please. Thank you.
Okay, the mark is here, so I'll just shift it. Is that all right? Okay. Hello, everyone. I'm Rahul Jadhav from Huawei. So what is this draft about? So we have been documenting most of the observations, most of the implementers' experiences in this draft, and its aim is to clarify 6550. In some cases, maybe fix it, and provide some implementation guidelines also in the course. If you see, if you have read the draft, you might see that there are questions. So every section has a questions asking it, should we do it in this way or other way? So it's essentially from the implementation perspective, you have multiple ways of implementing certain things, and each of it might have some implications. So that's what this draft clarifies, and it's mostly the observations. But just to be clear, we might not publish this draft, but we might eventually keep it for a long term over a period of time. So the first observation is regarding the parent switching operation, wherein there is an element, there is a field called as DTSN, the destination advertisement trigger sequence number, and it has a very large implication and on the overall control overhead of Ripple. Am I doing something wrong here?
No, just trying to, if it's full screen, then it will advance properly.
Oh, okay.
No, but it doesn't take it.
It doesn't take it, so you have to do the thing.
Yeah, I have to.
Right. So this field is something which is sent into DIO, which informs the downstream peers to update the DAO, basically update the destination advertisement. Now, it's very easy to handle this in non-storing mode because it is directly controlled by the root. The DTSN value is directly controlled by the root. In case of storing mode of operation, it becomes a little bit tricky, and there are multiple implementation strategies possible. Now, an example here, when the node D switches from B to C, now node D needs to, on C needs to have not only the information about node D, but all the complete subdodag rooted at node D. Now, either D can update the DTSN, increment the DTSN, and reset the DIO trickle timer, in which case node D's DAO can go to C, but subdodag also has to be updated. That is one of the way to handle it, and I've seen the some implementations doing it. The other way is node D already has the routing information on behalf of all the nodes, and it sends an aggregated DAO on behalf of subdodag. While this is a great option, there are certain issues handling this, is because if the subdodag is quite big, it would mean sending a lot of DAOs to C. Every DAO has a sequence number, and the state information becomes too large to handle implementation wise. So it has a direct impact on the RAM and things like that. You have to maintain the state while you fragment the DAO and then send it. So one of the implementation, right, what it does is it just pushes all the subdodag information, all the targets into the same DAO and leaves it to the 6-slow for fragmenting it. That is one option. But then we have seen that it has a very, I mean, if you have like 20 nodes below yours, below you, then the DAO object is really big object. In which case it results in more than 5 fragments. In which case the performance at 6-slow fragmentation goes bad. Maybe the other minimal fragment can help there, but
not minimal. Well,
right.
It's just one hop. So
okay. So yeah, again, but it also definitely has an implication on RAM because you have a different DAO sequence, and if you enable acknowledgement for each of these DAOs, you have to keep. You might want to keep the information in the memory while you are retransmitting it.
Yeah, Pascal, you were here. So yes, I see that the specification is not very specific about exactly what you say. At least what was in mind is your option 2. That is, if you're if you're in storing mode, at the end of the day, you need to have this state about all the children and children of children, of all the descendants. You need to have it. So even if you do your option 1, which will recursively do the DTSN all the way down, you will end up in node C with all the state that you talk about, because that's storing mode. So at the end of the day, you need a state for all the children, and you need to know the latest path sequence for all the children. You need that state. So version 2 that you mentioned, when D rebuilds all these big DAO to C, is just the same result without the churn sending the DTSN all the way down. But at the end of the day, the amount of state in C is the same. It's the collection of children. So that doesn't change the amount of state at the end. It just changes how much messaging goes through. And I would think that in terms of bytes in the air, if you have to go all the way to G for G to do the DAO, it's more bytes in the air than if D reconstructs it. I would also argue that we should pack many targets into a single DAO, make the DAO as big as possible, but reasonably big, because after that, the transmission has a chance to fail. Right, so it's not one DAO hack per target. It's DAO hack per packed targets at least.
Right.
But yes, we have to pass this information on. The best thing we can do next is to compress it as much as we can. Like in projected DAO, we use RSC 8138 to compress the VR options. At some point, we could use that same compression in the DAO if we really want to try to make it not as big.
So since you brought up the compression issue here, there's one more observation that we have in context of this compression. Every target, and most likely whatever the target information that D has, each one of the target has a different path sequence and a different path lifetime. So what happens is, it is not possible to aggregate multiple targets to the same transit information option. So you have one target transit information option for every target, two options going out for every. So I mean that's really too much of control overhead per target. Having said that, what you said is C needs to have all the information, and if you do reset trickle timer and increment the DTSN, it is definitely going to cause more control overhead, whatever we do, as compared to descending the aggregated DAO. That is very clear, but it is goddamn easy to implement. And I can see that implementers have chosen the shortcut, and it's very easy to implement. Yeah.
Michael Richardson. So I have, I think, 3 questions. And we've talked about this, since the first version of your draft, which maybe was 3 years ago, right? Okay. So I think that this may be appropriate for, I don't know if we want to put this in a separate draft or just writing it down as an errata for 6550 for the moment. Once we have working group consensus on the right answer, I mean, we can leave it in your draft, but I'm not sure procedurally what we will do with the conclusion. I think we can make a conclusion finally for this. We should.
Yeah, sure.
So that was my first question. I'm not sure what the procedural next step once we decide on a point. The second question is, is there an interoperability issue here with whether or not the decision about node D does one or the other?
There is, so great that you brought up this point with regards to interoperability. Now, the handling of aggregated DAO, well, the RFC doesn't mandate it. I mean, so RFC doesn't say, so we already have implementation. We don't, Riot and Contiki doesn't work at multiple hops today.
So going with the second option doesn't work because the handling of the aggregated DAO is not clearly articulated in the document. So there's an errata right now where we can say, thou shalt handle multiple DAOs. Okay, and so we have an interoperability issue. In the meantime, incrementing the DTSN is a good thing, and we don't know whether the downstream. Is that on the sender or the receiver? So that's on C that has the issue.
No, C doesn't have an issue. So it's the sender D who needs to decide whether to send aggregated DAO or just.
Well, the D knows whether he handles aggregated DAOs or not. He doesn't know if C handles aggregated DAOs. Right. So we do have an interop. It's not a unilateral decision. I know I implement this code, therefore I'm okay. Because he doesn't know, the best he can do is send whether he increments DTSN or just resends the data he's already got. The most pessimistic thing he has to do is send single DAOs, single prefixes per DAO, right? If you understand what I'm saying, Pascal?
I'm just saying, we seem to be mixing 2 problems, right? Just to clarify, the problem 1, which is whether D answers for all the children. And problem 2 is whether D packages them as few messages with a lot of targets in them or as one big message with all the targets in them. Two problems. Yeah. Right. So my argument was sending the TSN recursively down is quote unquote a bad idea, and to which Raul said yes, but it's very easy to do something like that. But it's a bad idea.
And it's not just that it's easier to do; it's that it results in single DAOs coming back up, and therefore you don't have to package them.
But you can do single or multiple, and it does not necessarily. No, it's not an Oreo. I mean, if D decides to build single DAO, it will build 1,000 of them, but it can package them one by one if it likes to, right? It's not because he has them in memory that he has to pack them. So it's orthogonal.
I agree with you.
And same thing, I mean, if the guy below you did aggregation, you just forward what you get, it would be aggregated for you, you wouldn't know. So I think it's really two different problems we should separate.
Okay, so that's a good observation. So that the multiple DAO, we have a problem with interoperability, and we have this problem where it's nothing to do with packet switching. We just have that problem of there, and it causes an issue.
Right.
Okay. It sounds like everyone would like to use solution B. It's a better answer. We just don't know whether we can or not.
Right.
That's the point.
Yeah.
Okay. So having said that, I want to ask, not that many people in the room, how many people have storing MOP are using it? You're using it, and you're having difficulty across devices. Okay. Anyone? Sorry, I didn't see behind me if anyone put their hand up. Okay. So Anima ACP is using storing, right? We could probably at this point, say which one mattered or something like that. It's early days enough to do that. I feel that we shouldn't spend this is my third point, we shouldn't spend too much time agonizing over this issue. It's not worth, I don't know if it's worth the capability to solve the multiple DAO point or not. Like we could have a capabilities we've discussed elsewhere, right? Find out if all the nodes support packing DAOs and multiple DAOs in a single message, and if that's the case, we can say it's enabled because everyone supports it, right? That would be an example of using the capability mechanism, right, to fix this. I'm not sure that's worthwhile for the simple reason that I think we would be way better off to have non-storing mode with projected DAO as the replacement regardless, okay? And we may just want to write the errata that says you should support multiple DAOs. If you don't, you have a bug, and you should you should resend them when you change parents from your storage rather than incrementing the DTSN.
Right. Yeah.
Okay, we could write those two things down and not really worry about the fact that we may have a backward compatibility issue with something.
Yeah, so
okay?
Right.
That's my suggestion. Right. And then we can take that slide off your deck and go on to the next one.
Yes.
Right?
Yes.
So I don't know if you want to, that's my suggestion, and we could hum on it or whatever we want to do.
Okay. All right. Okay. Okay, so again, we coming to another topic which we have discussed before, but there are some updates on this this handling. So the DAO-ACK handling, again, this is not much of an issue when you handle it in non-storing MOP, because as you can see here in the diagram, that the root node is going to send the DAO-ACK back to the D. Now that DAO-ACK is extremely important for any implementation, because that is the signaling which gives you an indication that the application traffic can begin. That is the only indication available on a big network that the application traffic can be instantiated. So this is an extremely important point. So DAO-ACK needs to be handled in that sense. So in case of non-storing mode, it is really, really simple, because the root node, if it informs about the DAO-ACK, everyone is clear. In case of storing MOP, now, again, what we have is the DAO-ACK is sent on every hop by hop basis. Now node B here, when the node B sends the DAO to node B, it sends a DAO-ACK instantaneously, and relies on node B to reliably send the DAO all the way to its upstream peer. Now there are two problems with this this implementation or this methodology. One is, if the node B is going to instantly respond back with the DAO-ACK is no more an indication of starting instantiating the traffic. So you can't, the node here, which might be like 10 hops deep, should not really instantiate its application traffic just because it got a DAO-ACK back from an immediate upstream peer. That is one issue here. The second issue is, node B, for whatever reason it sends it upwards, there are reasons that node A might report a failure, DAO ACK failure with a negative status. And since the DAO ACK has already been reported downstream, the negative status cannot be reported any further below. So that is another issue. So in storing MOP, we really have a problem how to handle DAO ACK. Yes, possible.
Yes, I have two things here. First, just sorry to be back, but time for me to dig the RFC. There is a sentence in REPL which says the REPL target option may be repeated as necessary to indicate multiple targets. I was surprised by your comment that you could not aggregate or package, because we did it. So I always thought we should be doing it. I was surprised that the text was gone from REPL, but it's there. It's expected that you can package multiple targets. Sorry, that was fault.
Okay.
So this prompt has not really.
Yeah.
It's an implementation bug. So it's good to have an implementation recommendation. I completely love the idea, and we should have like the side document of yours, or maybe have a section for recommendations.
Right.
And that one, it's actually to implement. It's recommended to do what the RC says.
Okay.
So for this, I agree. And when you wrote this RFC, this document, it was true, but since then you wrote another document. Which is DCO, and so if we wanted to, we can explain how DCO can be used in that case.
No, sorry, I didn't get the context of DCO in this context. So how does
Well, if you have the DAO ACK prime down there, you can kill the path to say I could not make it.
So you're saying the DCO again, but yeah, it still does not solve the first issue, right? And which is the primary design consideration.
Yes, you cannot start the traffic immediately. The traffic back would not come. That's true.
I mean, is there any other way for the node to know when to start the application traffic apart from this? Is what my other question would be to to the reversal group.
So this is true.
So it's non-storing. Michael Richardson again. It's non-storing mode. So if, and your example is, so the DAO ACK or the DAO from B to A has failed. Okay, D thought it could send traffic. It's non-storing mode. So excuse me, it's storing mode. So so the issue is that if D starts sending traffic up to B, traffic will not come back. Right. So he can send traffic and it can go out to the network if he's sending, unidirectional traffic. Cool. Traffic coming back doesn't work. So if you try to do TCP or CoAP, okay, for instance, which has a response, then you're not going to get an answer. Okay. Well, that happens, right? That's okay. That happens. That's part of the world, right? Okay. If B does have a route, let's say that's a bad example, but let's use the case of F to D, okay? And D knows, and the traffic is to C, because it's destined to C. Well, D knows how to get their C. The fact that B and A don't know how to get to F yet, not so important, because the traffic's going to C. C actually has, could be going back by two ways, but so that's okay. That traffic works, and I guess I would say it would be okay to say DAO ACK means start traffic, but of course traffic isn't always reliable.
Yeah. So
right.
Yeah. So it's just that in this case, all the nodes downstream starts their application traffic, which simply aggravates the situation. So if there are a lot of nodes below, so it not only impacts the application traffic, but also the other control traffic in the network. So the situation simply goes bad. The network convergence time is impacted terribly. That's what.
Hi, Alvaro Rotana, FutureWay Networks, speaking as a working group contributor. I kind of like the DCO option, just your killer path, assuming we add a reason to the other draft and all that stuff. But what I was going to say is that what other protocols do is that they, of course, wait till the root acts before acting down.
That's the next slide.
That's the next slide?
I think so.
That's the next slide. Yeah. Yeah. So there is another DAO ACK interpretation, which is essentially what Alvaro you're mentioning. So usually this is the case. Node D sends DAO to B and it simply acknowledges back. In other case, the DAO is sent all the way back to the root and then root acknowledges it back. While this is great, I mean, it definitely is a clear indication of once the node gets the DAO acknowledgement, it's a clear indication that the application traffic can be begun, but it has implications on the state information that has to be maintained on these nodes, intermediate hops. So that state information is on per, that is enormous. I mean, even if you add 1 byte, it means you have to add 1 byte in the routing table, which is kind of huge.
Pascal Tumer, just to give Alvaro fuller context on the design. So the official design is first one. You acknowledge per. And by acknowledging, you say, hey, I have the resources. You don't say, I have the path, right? That's the problem. But we say, I have the resources, meaning that you take over responsibility to propagate the routing to the root, meaning also that if you fail to do that, then you will actually have to kill your relationship with that child because you can't serve him as a parent. So that's how recursively today it will reach the children. The problem with that is the only way to do this, because we didn't have DCO, was to actually completely stop being a router for this guy. And so he would have to find another parent through which the path would work. And that would happen somewhere like in node A, for instance, even if you're serving node D, if node A doesn't have enough resources for all its children. So node B trying to forward the DAO would get a bad response. And today, the only way for node B, well, node A would basically have to stop being a router for node B, and hopefully node B would find another path, or it would be disconnected. If it's disconnected, you poison the graph, blah, blah, blah. So it's not like you're stuck. There is something which will happen eventually. Like either you're detached or the packet will find its way. So the only real problem is you don't know how much to wait till you've got your routing back. So you don't have any assurance coming from the root saying, okay, now I see you, right? But it's not like we're in a situation where the protocol would be stuck in a state, everybody's waiting, nothing happening. So there is always a next step, which may end up breaking everything, but at least you know about it.
The important point is the last point in the slide, though.
Well, the other scheme does not exist. I mean, so this scheme that the world is talking about is a trick that was implemented by Contiki because they wanted to do something, and it worked fine for them, because they wanted to make a product with power plugs, and so that's why you find it in Contiki, but it's not in the spec. The spec was never meant to do this second thing. It's not like that. I don't think there is ambiguity there. You did it. Wow. Okay. Well, that was not meant to be.
Wrong. That's why.
Because the problem with that is what kind of timeout do you have and how long? Because if the network is very slow, I mean, the DAO WAC, if you just send and it fails and you don't get an acknowledgement and you're there, and and it can be multi-hop, what would be your timeout? When do you start thinking, hey, it didn't work, I should try to fire another one? It's like wireless multi-hop. We do acknowledgement at every hops because otherwise it can be very, very slow. So what's your timeout if D, sends a DAO, which is supposed to be propagated and then come back, and anything can happen at every step. The timeout is kind of long now, and the retry is over all the path. So it's much more costly to recover than if you do it where it fails.
So Pascal, here we can call Contiki's implementation another interpretation of the draft, but they have not really violated any of the, any of the specifications.
Yes, okay. Yes, that was just not the intent. I have to take. You're probably correct. I think it's
okay. Yeah. So what is the desired way? So status is equal to 0 in DAO should serve as an indication that the path is established. Well, that I think is definitely needed in storing mode of operation, in any mode of operation for that matter. And we are hoping that there should not be any explicit state that should be required to be maintained on intermediate 6 LRs for DAO hacking. And if at the same time we can handle DAO aggregation, that will be really great. So going to the next point here about signaling resource constraints. How are we doing with the time? Yeah, all right. So signaling resource constraints. So the point here is that mentioned that is, let's say node D has gone through node B, and node B has limited resources, and some of the nodes in the subdoodles have already attached to node D, but now it cannot take any nodes further. So we don't have any metric system to percolate this information downwards. Now we have enrollment priority, which is coming up. It's a step in that direction, but it helps at a single hop, is what my understanding is. And if we need to go further down, if we need to send this information further down, we need to somehow put this information into the metrics constraints using 6554 and then handle it.
We try to write a draft on this, providing this information through the DIO package. And the metric was the remaining resource that we have.
Remaining resources, right. I've seen, yeah.
So and then we translated this to the enrollment priority that Michael wrote a draft. But for the moment, it's not accepted.
And Michael again. So if I recall, was it your draft that had a whole bunch of unbalanced trees? Yes. Okay. So I don't understand the last point, but needs to be usable at multiple hops. Maybe I don't. Maybe that's wrong, or maybe I just don't understand the point. Why is it not usable at multiple hops? Meaning it's not A can't tell C that it's out of space, or
no. If B, so let's say for example, this is the routing. This is the same example. If we take, if node H is going to send a DAO, it goes through F, it goes through D, and then finally it ends up at B. But B responds back with a negative status. Now only H has to be impacted, not D and F. So there is no point in D switching.
Oh, I see. I see. The point is that D would switch when B said I haven't got any space.
Right.
That would cause D to switch to C. Well, C might not have space for the whole thing either. Right. And the answer is that somehow the tree has to be split across B and C, but F is in the way. We can't, in this network, F has to pick one parent or the other.
Correct.
Right. Yeah. So it can't. Maybe there is no solution.
Yeah, there is no solution as of now. I mean, right now, if you see that the other draft that Giorgio was talking about, it doesn't handle the solution the scenario that you just mentioned.
Right. So we can't solve the problem that B and C don't have enough space for D, F, G, and H. There, if neither have enough space, it doesn't matter where D goes. You're stuck.
Right.
And we can look down at it as God and see that the problem's not solvable. So the fact that we can't signal it's maybe not so important. We would have to do something else. F would have to somehow be able to have two parents, D and E, to split, if that were possible. And I guess F somehow has enough space for G and H, but the combination of G, H, and F is too much and D is too much for the nodes above, right? Because we could assume there's other part of the tree as well.
Yeah, this usually happens if you have a lot of nodes. If you have 1,000 nodes network and somewhere upstream, the situation is quite easy to be. It can be very easily produced there.
Yeah, so we spent a lot of time when we devised the first REPL wondering if we should be doing something for that problem. And actually, I was favoring being at least able to say, hey, I can't take more resource, just status at least, right? So you can push back children to the left, to the right. Whatever you do in the distributed fashion like this, since it's an NP-complete problem at the end of the day, you can only push back and push back and push back. As you put more and more complex stuff in the solution space, you and signaling and stuff, you push back the problem a little bit and another little bit and another little bit. And it's exponentially difficult and you win exponentially less or whatever. So we spoke a lot, and people said this document is too thick already, so let's not make REPL more complex. And that's how we ended up with this constraint that basically any node, whether it's G or A, should have enough resources in storing mode for the whole network, quote unquote, or almost all, enough storing mode space, whichever your position in the graph. And if you want to, if for instance, if you have enough memory for 100 nodes on the box, you should say don't build a network with more than 100 nodes with this device in storing mode. That's kind of what the conclusion was. We said anything else is just incremental and too complicated, blah blah blah. So it's kind of a decision we took at the time that can be revised. that, in a distributed fashion, it's very, very hard to do other things. So we prefer work on NPDAO or things like that.
Right. So just to come to that point, I mean, it is completely, I mean, I understand that we take a decision about making, taking this decision that node F, D, E, all these nodes should have enough resources to hold the complete, but this design assumption never came into 6550, and people who are deploying it eventually realize at a later stage that this could be a very big issue, and that is what is one of the points that should be mentioned somewhere.
Oh yeah,
at least.
Sure. Yeah. Sure, but it's the only point is it's not even a developer recommendation. It's not an LWIG type of thing. It's a deployment type of thing, right? When you build a product, when you use a product, you should not use storing mode in the network. It's bigger than this product can do. So it's even it's not even implementation recommendation like other things, right? It's even deeper. Yeah.
Yeah. The use case document says that we should be using storing mode for we can use storing mode for thousands of network nodes. At least that document, maybe we should have captured it. Or what do you think? How can we capture such?
It depends on what device you use, right? I mean, 1,000 nodes is a few 10,000, well, maybe 100K memory. For some box, 100K is nothing. For some others, it's impossible. I mean, you can have a power grid meter, which is always powered, and that costs thousands of dollars anyway. So having 1 meg of memory in it is no problem. So this is a layer 3 protocol. It doesn't really make assumptions on what the hardware, or even if it's a radio. Right? We said Anima uses Ripple on Ethernet. So there's no assumption at layer 3. It's just that if you really want to use it in a constrained network with constrained devices, then yes, storing mode impacts the size of the network with the memory you can put into it. So it should be written somewhere. I agree.
Yeah, I'm just glad that we have this on record that we need the nodes to be equally capable, all the nodes from resource wise, if you really want storing more MOP to be used. Yeah. Okay, going to the next point here. The transit information option, the design goal of transit information option was to make sure that we map one or more transit information to one or more targets, provide a syntax for aggregating common transit information option. But then what I can see, and maybe I would like to be corrected from the working group, the certain elements of the transit information option, for example, the external, is not with regards to the transit, right? It's a target specific flag. Similarly, the path sequence and path lifetime. These characteristics are not related to, I mean, it is about specific target. Now what happens is once you have these target specific options, information going into transit information option, the aggregation options are limited. Now you can't have multiple targets pointing to the same transit information option.
Completely agree, Pascal, here again. This is only meant for, if I have this device and it has multiple either tethered devices like leaves, which would be tethered to it, or multiple addresses into this device, then you can aggregate it this way because you will advertise them as a package every time. But that's the only case, pretty much.
But just some time back, we talked about that the same mechanism is going to be used in context of parent switching.
Parents.
I mean, we discussed now, right, that we need aggregated DAOs in context of parent switching.
Yes,
we use aggregated
you will
DAOs.
need the TIO and the target and the TIO and the target and the target.
Yeah.
As many. You don't factor. This is factorization we're talking about.
Right.
So factorizing a transit for multiple targets works if all those targets are kind of collocated. So collocated meaning, for instance, a Ripple unaware leaf which would not even understand the rule draft. So it could not be mobile at all. It would be physically attached to the Ripple router, just like a card or USB cable or whatever else. And so you could have a number of addresses that are really packed together from where they are attached in the Ripple network, in which case you could factorize them with a TIO. But that's the only case I have in mind where this could happen.
Yeah, okay. So just one question. So in case of unaware leaves, we still have the path lifetime which has been informed, which may be informed from the unaware leaf through ND, right? I mean, it's still, the path lifetime might still eventually be derived from ND, then propagated by RPL
Yes,
upstream.
in this case, it's not factorizable.
Yeah,
I was meaning tethered in really like completely slave.
Okay.
The rule draft with 8505 decouples the two. So the rule node can move from one parent to the another. And that's when it needs to be able to have its own path sequence. Because the path will be injected on a different path.
Right.
And they will compare to common parent somewhere with the path sequence. But if the device itself cannot provide the path sequence, it cannot move. And then if it cannot move, that's what I mean by tethered, physically attached.
Yeah. So in this case, the device cannot give us a path sequence, but it can give us a path lifetime.
Well, there is no protocol for that, right? 8505 is the protocol for both. So I expect that a device that's tethered is an IPv6 host with 802.0.0, but nothing like 8505. So since we have nothing else, it means that it's just doing normal, even normal ND, I don't know, right? And so the Ripple router would learn that the device is here through snooping ND or weird stuff, and then it would translate that into Ripple if it likes. We don't have a spec for that. It's doable. I don't want to write a spec for that because we have 8505. But that's what I mean, tethered. I mean, this could be the router that does the Ripple router could be a big router. It could have multiple Ethernet interfaces on which you could plug physically some devices, or it could be USB ports, and it would just report them together. So it's a possibility. That's when you factorize.
Right. So basically, we still say that we have one TI or one target for
most of the time. Yeah,
most of the time.
Like 99.999.
Yeah. All right. 10 minutes. All right. So eliding options. Maybe I won't talk much about this. The only thing is, we have the draft updated for this. There is a scenario where you can't. So RFC 6550 already says that configuration option can be elided, but there is a scenario where it cannot be. So we had updated the observation draft, but I'm not going to talk into detail about this because we already have another draft about this. So we'll discuss about this. Yeah, right. It's the whole purpose of having that draft. The next part, and I really would like to have a clear conclusion on this, that regarding the RPL persistent state that has to be maintained. Now, for every lollipop counter, for the linear part, we need a persistent memory, persistent storage. If we do not have a persistent storage, it is possible that there are a lot of scenarios where a node might not be able to join in the network for a long, long time. Now, the question is whether, so we had discussed this back, and we have a clear understanding that if the node reboots during the linear part, there is no way to know that it has rebooted, or the other nodes, it is not possible for it to know that it is rebooted. And this is a very important problem to handle because nodes might get rebooted a lot of times.
Pascal, yes. Two things. The first one is you have to adjust the linear part so you avoid this problem as much as you can. Second is when you're in the linear part, why do we have a linear part, right? Why don't we just have a 0.0? Many protocols just have a 0.0 and they skip 0 when you keep turning. So we have a linear part because we may lose some messages. So we want to have a chance to increase and still detect. So if I send a message that indicates that I rebooted and it's lost, then people will miss forever that they rebooted. So having a linear part gives me like 16 chances for people around me to realize that I have rebooted or something. Now, if I send one of those messages every year, then I will be all my life in linear part. If I use 16, right? Like 16 years. So obviously you need to tune the linear part with the frequency at which you send those messages.
Right.
And if you send them frequently, at least when you reboot, you just want to send a batch of them to make sure people heard it. Then you can keep it to 16. Now, if you decide to be very slow, shrink it.
Let's take an example of DTSN here. Let's take an example of DTSN. Now, if we follow the logic where DTSN doesn't get incremented when the parent switches, then it's hardly possible. So in this case, 6550 says recommends a sequence window of 16. In this case, it's very difficult for it to recover from that.
We should basically update that depending on which field it is. As I'm writing the PDAO, we have several sequence counters there. I give a different value for starting the lollipop. I say basically just, I don't remember, but something like 254. So it has very, very short linear part. I mean, yes, we just put 16 and it was mostly thought for DIOs and now, well, it's too much. Unless you really send them very rapidly, it's too much. I mean,
the problem with DTSN is we don't know how much is okay. For example, we can't even say 4 is okay, because even if we keep it 4, it may still take really, really long for nodes to recover if the DTSN information is lost. Because if we are not incrementing DTSN frequently.
But the point is, you should be. I mean, that's what I was trying to say. If you use a linear port, something should be. Basically, there is a tension between. You don't want to stay in that part long time. So if you have a big number, you should have a short interval. The problem with having DTSN in short interval. Well, the cool thing about it is that if some child missed that you upgraded the DTSN because you resend, increasing DTSN each time in a short interval, they will end up seeing it, so you will have the DAO. So that's the good news. Now, the bad news is that all your children will send you their stuff, and that you don't want. Because if so grandchildren, you will get that repeated 16 times. So basically, I think we should really think case by case and talk about how often, as you're in the linear case, you need to send them more often. And how long should that linear case be? And for DTSN, probably almost 0. I agree with you, DTSN is a bad idea. The linear part should not be that long. So it's 16 is just like the default for the general mechanism, but we should have stated, for this flow, for this message, this is the length of the linear part, which I'm doing now for PDAO. You will find, if you look at the latest PDAO, you will find that every sequence counter has a size of linear part, which is not 16. Yeah.
So what should we do? So basically, we have a lot of lollipop counters.
We should look at all of them one by one and provide a different increment value, and say words which are related with how frequently you send them.
Okay.
And so that it belongs to a very limited lifespan. After that, you're in the circular part.
Okay.
Once you're in the circular part, you can space what you send much more. Mm-hmm. But something around the fact that the trickle timer should stay, for instance, for those which are below trickle, they should stay small until you're in the circular part. Sure. We never wrote anything like that. Mm-hmm. But you should not trickle out if you're in the linear part.
Fair enough. Yeah. Okay, so this is an interesting topic because this talks about path control bits, and I'm not sure if there is any implementation which uses this stuff. Well, it occupies a lot of real estate in 6550, but no one uses it as far as I know as of now. Well, it provides a very flexible logic for having multiple downward routes. You can have multiple downward routes with preferred routing over these routes using path control bits. Now, the point that I'm trying to make here is path control bits, it's not an easy mechanism to implement at all. It completely directly implements the memory size and the program size, everything. But it might be useful in the future for 60-shot raw is what I personally believe, because it allows you to have multiple download routes and allows you to load balance and do things like that. Having said that, I don't know if there is any implementation which is compliant with the use of path control bits. In fact, almost every implementation is non-compliant with 6550 today, because 6550 says that a node must not unicast a DAO message that has no active bits set in the path control field set. I don't know of any implementation which is setting this bit correctly or handling this bit at all. So essentially, there is no implementation which implements 6552 appropriately.
Yes, and I thought Georgios would come to the mic here, but this is a basic thing. It's, even if it's complex, I mean, the result is kind of basics, because your picture illustrates that you can end up going through the same parts exactly. So there are new proposals which are a bit more intelligent than this.
Okay.
And so if nobody implemented it, it could be something we deprecate when we revisit REPL.
Okay.
For instance, the fact that you look at common grandparents allows you to ensure that you can do, you talk about row, right? Row has a lot to do with having redundant two parents having the same two children, so you can crisscross. And so this is not capable of doing this because you have no visibility of who's your current parent. So I think the new algorithms, such as Georgia's draft, are much more powerful than this. So if we end up thinking, hey, for row or 6 days, we want to do something like that, then I would tend to think that we need to look at the newer approaches and deprecate this.
But I think the new approach that we're talking about, I mean, I'm assuming you're talking about the NS extensions,
Yep.
In which case it has a different set of assumptions, the design consideration, including the security considerations, the security aspects. Overhearing requires you to have all the nodes using the same network key, while DIO requires, but in this case, what we are saying is the data path uses the shared key, which is a very big implication in my view.
Overhearing, yes, for overhearing packets.
Right.
Now, overhearing packets is one of the benefits you can do with the NSA extension, but at least it also builds you a path which has redundancy in the fact that those two parents see those two children. So the packet can even go from parent to parent, even in unicast with different keys, or this parent to this child, or this parent to this child. And they know that if you reach those two child, they can still forward to the same guidance. So you've got this intrication between two paths that go from the root to the child. That's one of the benefits of the draft. So it's not, you're not building, like, say, two paths which are far away from one another or that reconverge. You're building two paths which are intricated with one another. So you have redundancy at every hop of the way as much as you can, even if you don't overhear. So overhearing is a thing you can do because you've got this intrication. But the first thing you do is intricate the path as opposed to having bottleneck like this.
Okay.
Okay,
so yeah, all right. So, okay, so, right.
So it could be deprecated as far as that goes.
Right. So, okay, coming to the last, I'm almost done. The miscellaneous section, mandating support for reception of aggregated targets. I think we should clearly mention this in the draft somewhere in the aggregated DAO should be handled by the receiving node. Is it possible? Okay, the DAO ACK, I don't know why DAO ACK is mentioned as a should in 6550. Well, it should actually be must. So the receiver node might, on seeing a K flag, might still decide not to send DAO ACK. So that is what it means. In case of multi-DUDAG and multi-instance, I think, I mean, we still have a work in progress, but there are certain observations. Basically, one important observation that we have is, should the routing table be reset when switching from one DUDAG to another in the same instance? Not talking about different instance. So there are certain implementation practices which, I mean, implementers could be confused about when implementing multiple DUDAGs and multiple instances. Transit information option is an optional element, but I don't see how it can be optional at all. In case of non-storing mode as well as in storing mode, it has to be mandatory. But the draft says that it may be sent. The transit information option may be sent. I'm just wondering whether is it better for us to have some min RPL or something like that without path control bits. Anyways, most of the folks are not using path control bits. Condense the whole RPL logic into very specific, memory optimized, and maybe we have a clear assumption saying that it works only for such kind of devices, and the general RPL can work for bigger set of devices, including Ethernet and things like that for ACP use case. But can we have a min RPL like thing? So that is one of the questions that I would like to ask to this working group. Having said that, the DAO ACK, there are some possibly I know that Rabi is working on the prototype and draft draft which clarifies how to he was not in time for this IETF, but he's trying to prototype and try to get some numbers as in the control overhead and all that. So DAO ACK, there is one more option that he's trying to check whether, just like non-storing mode, if we have a DAO ACK reported back from the root to the node, what it means, what will it result into? So,
Pascal, once you have the DCO and you have statuses below 128, which allow you to do anything you like, which is positive, you could have a state in the DCO value below 128, which is triggered by a new bit in the DAO. And when it reaches the root, the root is this bit, just fire a DCO with status 1, 2.
So I'm just worried about the other case that we talked about, about instantiating the app traffic. So you need DAO ACK to even know, for the node to know whether it can instantiate the app traffic. So if the DCO is the case where you can clean up the route if there is a negative failure.
Yeah, but if you extend the thinking of DCO, it's a very powerful thing. It's the only message we have going down the DODAG. And so for now, it was meant to destroy something. But as written, now it carries a REPL status. I mean, it was very recent, but it has the REPL status in it.
Wow, okay.
And for now, it's always considered as an error to send a DCO. But since we can report a status below 128, and it's not yet sent to the RFC editor, you could still say, hey, by the way, there is this new statuses which mean those new things. Oh. And one status DCO sent by the route down, and you see where I'm going.
I get it.
Could just mean, hey, the route is open, fire. But if you get the DCO from the route, it means you can reach you. Now, it's not telling you you can go, you can do anything. It just tells you the route can reach you, because the rest of the internet may be broken. You have no guarantee there. Co-op may still not work.
Maybe the name that we used was not right. Maybe we should not have called it cleanup object.
Oh yeah, I mean it's a powerful
thing.
But
I get the point what you're trying to say. Yeah.
Don't reduce it to too small. I mean let's try to keep open the options we have here.
Okay.
So it's still in our hands. So it's not for Alvaro, right? I hope he heard. So the bottom line is DCO is a powerful tool. We can use it for more than just cleaning a path. Because now we have a REPL status in it, and the REPL status below 128 could be more information like, oh, I'm the route, and I can reach you now. So we can do the hop by hop hack, but a flag in the DAO, when it reaches the route, could trigger a DCO from the route back to the node saying, oh, all set, we can fire. If we wanted to, right? It's just that having a message just for one purpose, since it's the only message that goes down, I think it's a bit of a waste. Now we see more value of using DCO for, and we can forget what DCO is about, as long, yeah, or find a new acronym, something which stays DCO but is more generic.
Okay, thank you for bringing that up. Yeah, okay. So there's still some other points which are uncovered, which possibly might get updated in the future version of the draft. It's about the multi-sync and border router practices. If an implementation has to use multiple syncs, multiple border routers, multiple DODAGs, what are the best implementation practices that one should follow? The multicast operations, there are a lot of configuration items in multicast operations which have to be synchronized appropriately to all the nodes. Secondly, the SMRF and ESMRF, while it has been widely used in the networks, it has not been standardized for some reason. It seems, I don't know if there has been any attempt of standardizing such things. The next part is the partial dependency on ND. So now today we have prefix information option, which is part of RPL, but there is a whole lot of other information. For example, the DNS configuration, which needs to be given from the border router all the way to the node. This information still relies on the RSRA kind of signaling mechanism. So should we really have this partial dependency on ND still with REPL? Is another question. Yeah, that's all.
Thank you very much. Mike?
Michael Richardson. I would like to say that if I would be very happy to put context stuff into DIOs and be okay without ND. I think that's okay. The corollary is that, we've made some effort to, or the converse is we've made some effort to support unaware leaves. So we actually need ND for all of that. So I would say that's, kind of here nor there. And maybe the answer is we should put it in the DIOs for networks that have no leaves, and if we have routers that expect 6LRs that expect to have leaves, because that's the kind of network there are, then they should do it that way. But I don't know.
The example that I gave, the DNS configuration, it's a must-have thing for all the nodes. It simply doesn't have it today. If you are actually connecting to the internet directly from the node, without any for all.
Well, but you can also use DHCP, right? So it goes all the way up to the top to get that info. I mean, I mean, it may be expensive, but DNS lookups are going to do that too. So if you really are doing DNS lookups, then, you know, I don't know. I maybe we should have a conversation about configuration information. Okay.
Okay. So Pascal here. The cool thing is now we have the capability to hide configuration information, meaning that now we can be a lot richer in what we push in the configuration. That's good news.
That sounds good.
For this particular thing, there was a lot of discussion till the end of REPL, where, for instance, for the SLLA option, because there's one thing is those implementations which don't rely on RSRA, but just on DIOs, they are violating IPv6 because you're supposed to resolve the address of the router using an RS multicast and RA unicast back. That's ND. And if you just wait for a DIO and pick the MAC address of the router from there, you're violating. Now, it would have been very, very easy to put a source link layer address in the DIO, for instance. It was a fight. I lost. It's not there. Because we wanted to keep the spec and the implementation thin or something. So, I mean, there are pros and cons. It's not like it's obvious. But the bottom line is at the time we could not elide option. So now we can. Okay. What does it bring us?
So just before I move out of this, I just want to state that the next attempt for this draft would be to actually get some numbers in terms of the control overhead that are being caused by these different mechanisms, and tell the working group what implication it might have, over the different.
So another information that may be useful. In my original mind, the DIO was an option in an array. It was a radio array with DIO. And people, mailing list, we agreed to split that. And I think the most acceptable reason for splitting was that some information that you usually find in an array is sent at a different pace and for different reasons than for some information that you find at DIO, right? So you can expect that in a network like this, the array will be a lot less frequent than a DIO. Now, the problem is, if the array are not frequent, it might be that the first thing that node sees is a DIO, right? Well, a beacon and then a DIO. So you don't want to wait for an array after you got the DIO, which could be a long time. So now you end up broadcasting an RS. And so you wonder if you could put enough information that you don't need the array for the REPL stuff, which is, I guess, your point. Then you could start working right away. And actually, the way we did REPL, we really expected to put ND options, just change them minimum, which is just the avoid the alignment, and so express things in bytes as opposed to octet to 4 bytes. So just change the unit and the size. And look at the PIO, that's exactly what it is, right? So it's really meant to package more options, really. It's just that we didn't do it.
Okay.
So I'm fully supportive if you start something like that.
Thank you.
Thank you very much, Raul. Please volunteer if you want to do some implementation about what the topics that Raul say would be very useful. Or if you want to write, you can start with the lollipop counters, like a document. How can I print each counter that we have in REPL? You can start writing. Volunteer and contact us or Raul. How can you help us? I mean, there is a lot of work to do, and we are happy to have newcomers. Just let's have some fun. Thank you. Now, Pascal.
Okay. So thank you, Ines. Oh, actually, I don't need this, right? So yes, this is about the projected DAO document. So we did a lot of work in the last month since last IETF on PDAO and on the rule. So last IETF, we decided a number of things, and I will go through them. We decided to add more capabilities to the PDAO draft. And so I tried to propose things on email. Didn't get a lot of responses. So I thought, hey, let me write down and publish starting points. So they are not fully agreed by the groups. That's why I'm presenting them today. And I really expect that I'll get feedback from you guys. Is it taking the right path? But since we added all these new things, I expect churn in the document till all of those things settle to something that the group likes. And that's why December is not a feasible date because of all those additions we made. Okay, so I think you tried all the ways to be, because there is another button somewhere which.
But they say here.
Yes, you have to. There is a button there.
And this one is the one that.
Yes, and you get another button. You have two things to do.
Okay.
So yes, this one.
There's an order to it.
And then push the other one. Nudge it work.
Then it's work.
Yeah.
Yes.
Yeah. Thank you.
So I have two slides just for the changes highlight, and it's just the highlights. So yes, I mean, you've seen that the number has increased as well. So the first thing we said we should be doing, and this one was easy, is the VIA option is big because you have a sequence of IPv6 addresses. So what we decided to do is compress it, and it's very easy because 813.8 says, okay, you take a reference address, and you just have to put the bytes which are different from that address. The only thing is you have the same compression for all the addresses in the PDAO. So either you put more segments, or you just have to use the same number of bytes for every address, because that's what the compression value tells you. So as written right now, a PDAO is a segment, and the segment has the same compression for all the addresses. So if one could be compressed to 2 bytes, but the next is to 4 bytes, you align everybody to 4 bytes, which is pretty much the way we did in 6553 or something, whatever. Okay, so basically the VIA option now is much smaller because we can compress to 2 or 4 bytes or something like that. Second thing, it's related to a question that Michael placed in the mailing list, is how do you manage this thing? Creating it is good, but you need to delete it, you need to update it, and for that, you need to identify it in the first place. So we were missing an identifier for each path that we're creating, so we can say, hey, we're going to destroy it. And we needed the usual sequence, like the path lifetime and the path sequence, the exact same thing were needed. But first we needed a path ID. And if you read the 6-dish architecture, you will find that 6-dish already describes that. Actually, a path that we built in 6-dish is called a track, because path is so generic that you never know what you're talking about. Is it a multi-path, a single path? I mean, so track is more specific to what we're talking about. It's kind of a direct acyclic graph to a destination. So you can have some degree of redundancy to get to that destination. And REPL had a model for index those things, which is the local instance ID. So the local instance ID is a number which is taken from a namespace which belongs to the destination or the source of the packet. Since we are talking about a traffic engineered path to a certain destination, the packets always go to that destination. So it's kind of logical to take the number from the namespace of the destination. So it's just like you're used today, right? If you send a packet towards the root, well, if it's a global instance, you just look at the instance ID. But if it was a local instance to the root, the packet would be flagged so that the destination plus the local instance ID in the RPI tell you what DODAG that is, which tells you what routing table you need to look at to route this packet. So we just 6-dish said generalize that for tracks, and that's now replicated in this draft. So we're consistent between this draft and the 6-dish architecture. So the track ID is really a local REPL instance ID, which is associated with the destination address of the packet that flow in this DODAG towards that target.
Pascal, can I have a question here? How do we define this track? Like we have the ID, but how this path will be, this track will be defined, how it changes and so on. Then
so
how do you update it?
Basically, now you have a track ID. The root will send a new PDAO message to update it with the same track ID and a new path sequence, kind of. So, and the new path sequence kind of remove the old one, lifetime of 0, remove what you had. If you have the same sequence number, it's a retry. You should forward it the way it is, but you don't have to change anything because it's the same as before. So maybe it was lost a bit later. So that's Installing it is the good old PDAO that we had forever. But now it's more like being able to retry a packet that did not make its way all the way to the end, or update what you had, either kill it with a lifetime 0 or change something in the past, which was like this, now it's going like this. So you may need to kill the old one, install the new one, but maybe some hopes were common. So instead of discarding everything and recreating everything, you just want to update what you had. So now we can do all those because we have a sequence counter and a lifetime. And I will come back to that because there is another side effect of what we discussed last time. We were also missing a segment ID because a track is not a serial path. Why? Because if you have a controller up there outside of your, say typical Ripple network is a FAN, right? A field array network like smart grid. You do that, I do that. The controller is far away. The network is slow. So if you build only a serial path and there is some prime on that path, you need to go back to the controller to fix it. You don't have the time. So you really need the path to be very resilient. That's a raw problem. If the path is very resilient, it means it has multiple segments. It has one way north, one way south, and maybe replication elimination between those, and maybe several, even north, south, middle, blah, blah, blah. And they're all the same track. There are different segments on the same track. When you put all the segments together, you get the vision of the track. So we needed not only a track ID, but also a segment ID, so you could modify a segment without repainting the whole track. So the latest version that was missing in the previous version, the latest version that I published this morning, I added back those segment IDs which were missing. But it's the same problem as Michael said. How do you manage this thing? The first thing you need to manage it is to identify it. So this piece is solved. Now, if we don't have everything we need to manage it, then that will be discussion on the mailing list. Another thing we said we would be doing is add sibling information. Because initially when we wrote this draft, we said, oh, there will be another protocol to expose the logical structure to the root, and that's not PDAO. But nothing came up. And then we end up with a route projection mechanism, but no way to expose the topology to the root. And we said, hey, in storing mode, the root already knows the DAG, right? So the only thing that's really missing is a few siblings, and then the root has enough. So why don't we package that into PDAO?
Rahul Jadhav, Huawei. Strangely enough, I discovered that path control bits can actually do that. So in transit information option, it is possible, using transmits, it is possible for one target to send multiple transit information options with different parents to the root. And I discovered this very recently, that it is possible for the node to tell the root that it is attached to all the siblings.
Right, but they are parents. And so we needed to be able to signal something which was not a parent. And the problem with a non-parent is, well, you wanted to be able to signal like some metrics. And so basically the sibling information can have metric containers, and that was actually Robbie, I guess, who asked us. I don't remember. Somebody asked us. It was a great question. So now, since it was discussed on the mailing list, this one, it's not only a sibling, but also some metrics about, between you and this sibling. Very important, the sibling selection is out of scope. This is just signaling. You express to the root, I have this sibling, the root manages with that. Now say I'm in a very dense network, like thousands of nodes around me. I won't be able to report 1,000 siblings to the root. Worse than that, it's not only knowing that you have siblings, it's also maintaining bidirectional connectivity with them. Or at least having some packets between them so you know the signal strength. And so you realize that something will have to be done to select siblings in all directions so I can get anywhere, as opposed to taking, for instance, the 3 best neighbors, which are all on my right, so if I use them, I can never go left. So there is a problem of sibling selection, which is not addressed by this draft. I don't see that we should address it, because some networks, they don't need it because you have few siblings and you can report them all. Some other networks have different sort of siblings. And I see the sibling selection as an objective function problem. Just like the OF is separated from Ripple, the sibling selection could be various intelligences based on various networks. And I expect that we would see documents coming to roll just about objective function to select siblings. the result of that objective function would be I select those three siblings and now I report them to this thing. So this is more like REPO. We don't give the objective function. We say there is this plugin, and now we expect some different plugins for different situations to come up. Okay, so that's some highlights. Okay, I had this other request, at least by two people. I see that Lichao is on the Mythico, and there was another person who asked for it. Maybe Rabbi again, I don't remember. So there was, and there was, what's his name? Well, sorry. Well, I remember whom, but not his name. Anyway, so number of people asked for the capability for a node in the REPO network to say, hey, Mr. Root, I want a path to this other guy. So now we have a PDAO request and a PDAO request acknowledgement, which is a unicast packet to the root and back. And that's the response tells you, I'm Mr. Root and I have taken your program into account. And then you expect some PDAO to come back later. But at least an acknowledgement from the root that you understand that you asked him to do this. And the root will come back with a track ID in the response. So when you see the PDAO coming with this track ID, you know it's the one that is actually built for your request. And same thing, you have lifetime, so you can also ask the root to cancel it by putting a lifetime of 0, blah, blah, blah. I mean, so it's a simple mechanism. This one does not, I hope this did not need a lot of. In the future, and it's missing, and I don't know if you want to define it here, we might have something like a metric container, but the metrics would be about the quality of the path that you want to build. Like, if I want to say I want a path with 3 nines, which means that the root will have to compute, or the controller somewhere will have to compute maybe more paths, because with 2 paths, I can only have 2 nines. So, you know, being able to express the quality of the path that you want to build, the maximum latency or whatever else, that needs to be expressed as metrics. It's probably not exactly the type of things we have today in our metric containers. I don't know. So right now, I just note in this, when we remember, we know that when we ask for a path, we don't give like characteristics of the path we want to build. If we want to be able to indicate that, then we need to improve this section by saying, hey, here is a container of some form with the metrics which indicate the quality of the path you want to build. Up to you, up to the mailing list to say we need it. Then a lot of work on the INI, etc. We still need, and that's one of the issues we have, a better security section. So going to a little bit more details. So the new fields are here. Oh, by the way, just to differentiate what we do from the path, for instance, in the transit information, I renamed this thing track and segment because you have the 2 components, right? The track is a collection of segments. Maybe a track is just one segment if it's a serial path, but a track can also be a collection of segments. So instead of calling something path, and I don't know if it would be this thing or that thing that I should call path, I put a different name, track ID and segment ID. The track ID is a local REPO instance. You will find it in the packets associated with the destination. And so in the PDAO, you've got the target for the destination. So target plus track ID gives you the destination in the packet with the RPI. That's how you match one with the other. So by the way, doing this, we don't change the REPO data plane, right? We use the data plane as it stands.
Rahul Jadhav. So just to clarify here, so the track ID will be used eventually in the data plane as well, but segment ID won't. Segment ID is purely for management purpose.
Purely to build it.
Right.
So because you might have a VR for one segment and then another VR for the upper segment and lower segment. They are in the same track, but when you forward, you don't indicate which segment. That's, maybe you will tell me you need to, and then we change things. But the way the draft is written right now, we say put it on this track, and it's up to Rao, Wednesday morning. Please attend Rao Wednesday morning. It's up to Rao to make the decision of I'm using the upper segment, the lower segment, I'm using both, or I'm doing replication, elimination, overhearing, constructive interference, and whatever else. And so for each, you need a sequence, right? So both track sequence, which tell you when you flush the track you have and build a new one, and same thing for each segment individually within the same track. So if you see the same track sequence and the same fragments and same fragments segment sequence, what does that mean? Well, it probably means that you have a storing mode PDAO, which was sent by the root and the root never got an acknowledgement. So it's just retrying it. So the idea is when you get it, if you already got it, it has to be the same. So if you took actions like establishing routing state, it should still be valid. Maybe refresh the lifetime if it's really a short lifetime. But it's a retry. So it's just that somewhere down the path somebody lost it, the root is retrying it and expects an acknowledgement that it didn't get last time. And yes, I hope that we have a must somewhere to say the acknowledgement must. You must acknowledge. So here is the format of the packet, by the way, as I indicated. So this is new text. So remember, a local REPL instance ID in REPL is built like that. The first bit tells you if it's a global instance or a local instance. So instance 0 is a global instance. Instance 128 is a local instance. This bit, the second bit in the RPI is for the data path, not for the signaling. It tells you for a local instance, so if this bit says local, this bit tells you if it's local to the source or the destination. So if you use a DODAG in both directions, the address, which is the namespace for that instance, local instance, is on the way up, the destination, and on the way down, it's the source, right? So REPL has this notion of this bit, which tells you if it's the source or the destination, which is the namespace associated to this instance. In our case, a track is always going somewhere. It's never coming back. The traffic is directional, which means it's always the destination. So this bit is always, as always, same setting saying destination. Right. And then you get 64 value per address. So you can build 64 tracks, quote unquote, towards any given destination. Okay. So sibling information, what you have so far is a step of rank. So at least we give the rank expressed by the objective function as if it was a parent for which you would compute a step of rank, you use the same logic, and you look at the signal with this. You can at least signal the step of rank to the root. So at least the root can measure everything in terms of rank or step of rank. Now, we also have a sentence somewhere, since we had this discussion on mailing list, that you can have a metric container as an option to this thing. PDAO request. So ask for acknowledgement. And this is something to be discussed, but as I said, we are missing metrics to express the kind of quality we want for the build, for the path we build. So at least I put this little bit to remember that, to say I want a redundant path or not. Like, but maybe it's not the right way of signaling it. Maybe we need options or something to really say what kind of characteristics you want for this path that you want to create. So this is a packet that the node sends to the root. And the root answers with that. And so you get the lifetime, which is actually accepted by the root. You've got an echo of the sequence number, same thing for DAO-DAOAC. So you can correlate the request and the response. You get a status similar to the REPL status and the DCO status. So it tells you how good this worked. Pending issues. We've got the 2 tickets you mentioned, Ines. So first thing we'll do is go through this one in more details based on what we have now. Most of it is still relevant, and I'm really sorry, Michael, I missed it when it was there. Ines told me about it some time ago, and I had to finish what I was doing. But now we have like some base on which we can work, and let's address ticket 180. And there is a beginning of answers to some of the questions, like the fact we have the IDs, and now we can manage the tracks. And that's part of the discussion that Michael had about how you manage the damn thing. So part of the security was we have a to-do in the document about how PDAO messages can be abused. So that's part of the game. And, that's the configuration parameter I mentioned earlier. So do we want to push some parameters on the quality of the path that we want the root to build? So this is basically most needed things. So first step is, okay, there is a lot of change in the document, right? There's everything I told you and more details. So it's really good now that we settle and say, okay, let's look at all those proposals. Everything we said we would address last time is addressed in a certain fashion. Some of it was discussed on the mailing list. For some of this, I got responses. For some of this, I did not. So it would be really cool to set up and look at all this and say, okay, do we agree on the directions that were taken? Is it the way to go? And then we can progress. Missing segment information was published this morning, so it's done. Revamp formats to optimize. That's something we could look at now or in the future. Because right now there are a lot of reserved space here and there. Some of the formats that you've seen have 2 bytes reserved. Because I don't know what we'll discuss now, but before we ship, we might say, oh, those 2 bytes don't have to be reserved. We can just not send them. We have to basically look at those bits formats. And then that's when I say the best we can do for workgroup plus core is probably around next IETF. That would be just workgroup plus core, and then submitting to ISG would be like by summer or something. Voila.
Thank you very much, Pascal.
So
it's fine. We have 30 minutes. Questions? Who is willing to review this draft? Thank you. Thank you very much. Please in the comments.
So a lot of this is new. Feel free to re-challenge it. It's the right time.
Thank you, Pascal. Next, Raúl with.
No, I don't need this. I just use that. 25 minutes. All right. So there has been 2 interims, especially to discuss the capabilities and the MOPEX. And I'll just quickly give you an overview of what capabilities is. Most of you already know. It allows RPL nodes to signal their capabilities. Now, one of the things that we discussed last time was we need to clearly differentiate between what we already have mode of operation and the DIO configuration option. How is it different? How is capabilities going to be different? Now, one clear difference is that MOP in the configuration option is strictly root control. In case of capabilities, this could be sent by any of the nodes. So that is one of the most important difference. There should not, and capabilities can emit more richer information because it is sort of a format options TLV format by itself. And capabilities may be more dynamic than MOP and configuration. It might change over a period of time. Design goals, any node could generate the capability, an option could be sent in any message. So the other important thing is it should be possible for capabilities to work with existing mode of operation. Well, this is non-trivial. We'll discuss in the subsequent slides how this can be handled. And capabilities could be explicitly queried. Now, this is something that we have not handled as of now. How the capabilities could be queried from the node is a different question altogether, and we would really like to have some feedback from the working group on this point. How it looks right now, this is how it looks. So earlier, if you have read any earlier version of the draft, we had simply a combination of bits, but we have moved away from the combination of bits to individual TLE for each of this capability, because we might need more information in context to every capability that to be sent. So there is one more, there are a few more interesting bits in context to each of the capability. For example, the J bit, which is whether the node can join only as a leaf node if the capability is not understood, and whether the capability has to be copied downstream. And then the third bit is whether the capability information is present. Now, each capability might be optionally associated with additional set of information. If the I bit is set, that information is present, and if it is present, it has to be in this format. So during the interim, we discussed that we might need this length so that we can skip the whole option altogether. So I've added this length in the draft as well. Yeah. Handling cap unaware nodes. We try to reason if it is possible to handle the cap unaware nodes. And what we discussed in the interim was it is better to use capabilities only with the new mode of operation. So the new MOPEX allows you to send the old MOP in the new option. So if the new option is used, you can as well send caps with that. So caps is only supported only if the MOPEX is used. This is something which working group, it needs working group consideration as well. So the capability signaling, the capability, right? One thing that we discussed was the capabilities could be carried in existing signaling messages, the DIO DAOs, or it could be explicitly carried through signaled through some additional messaging, new messaging. This new messaging is yet to be discussed. This would be the right time if working group has a specific point to say here whether it is not good to have a new message altogether for querying the capability, but we need this querying mechanism. Or we could simply rely on this unicast this DIO to query this such kind of information, which I feel is not a good idea, because DIO has a lot of other information apart from the capabilities, which has to be given as well. So what can we use it now? For as of now, we have been discussing most of the capability options in context to the projected row, projected DAO, and the 6low RH, yeah. And we find that it is in a position to solve the needs of those two drafts. Right. MOPEX, where are we? So one of the things that has changed in context to the MOPEX is the final MOPEX value calculation. We don't use the complex. It was not complex, but it was still the multi-level calculation where you use the base MOP and the new MOP, add them together, and then you get a final MOP. We don't do that anymore. We use the MOPEX value as it is as the final MOP. So it's much simpler to understand. And secondly, we have that option of using old MOPs and continuing using the capability options with the old MOP. Yeah, Pascal.
Sorry, Raoul, time to jump on the mic. This is Pascal. Can you go back to the previous slide? Yes. So I want to insist on the difference between configuration and capability. For instance, in those two cases, projected route and 8138, the configuration is when the route imposes something, like you program the CLI in a router or something. So in this case, the configuration will say, and user free-pool info says it for its own use, go ahead and use this thing, set it up. And if you understand it, but you can't set it up, you should operate as a leaf or something. So you mentioned peer routes and 6low RH, but there's also the use of the new RPI in user free-pool info, right? So basically, you have a bit in the configuration option which says, use it. And it would be good that the root sets this when it knows that the node support it. That's when the capabilities come into play, right? So if you have another way to know that your devices support this, right, like for instance management, you don't need the capability, you still need the configuration, right? You use the management to know that the node support it, and once you're happy with that, you turn the feature on. Or if you just know your device and once you've uninstalled the last one which did not support or reflashed it, you know you have reflashed everyone. Now you can use the bit in the configuration to turn the function on. That's true for the new RPI. That's true for using projected route. Well, projected route a bit special, but that's true for 8138. So that's why we have those bits in the configuration. And that's one thing on the left. The thing on the right is how does the root know? And that's when the capability come into play. With this draft, we'll be capable to pull from the network what the network device do. So we don't need the management thing. The repo manages itself. So it's completely useful. It's separated from the configuration. We already did user free-pool info with a bit to configure. We need 8138 for the same thing. Peer route is more like the root will decide for just this route, so maybe it's not really, you don't really have a configuration for it. The PDAO is the configuration for it. But for RFC 8138 and for user free-pool, it's completely separate whether you can pull the capability and when you decide to configure it, right? So the other draft on 8138 does not need this one, you see, because it just says configure it. But when we have this, true for user free-pool info, true for 8138, then REPL will have a total solution to manage and configure. Okay, so that's how it's decoupled. So there is no, the idea that there is a dependency on this draft in user, well, trigger. I don't remember the 8138 draft.
Turn on 8138, right?
Yeah, well, no, there's no dependency. There's no need
Right.
to.
So just one question in this context. So where do we define the bed, the capability option for the node, which says that it supports 8138? Whether will it be in that draft or will it be in the capability draft or?
Well, my feeling is that we already shipped use of REPL info, and we don't want to delay use of REPL info to do the capability. So for use of REPL info, the answer is this draft will say it for use of REPL info. So I would say then this draft can also say it for 8138.
Okay.
So we keep consistent between the two, which means that 8138, a turn on 8138 can fly right away. And the reason why I'm kind of pushing for that is that we already need to be able to control 8138 today in the field. We would like to ship that like yesterday.
Okay.
And because now we are in a brown field really, and we have nodes which do, and nodes which don't. So we want to ship the new function capable of doing it, but we can't turn it on as long as it's a brown field. Right. And so the only way to address that is to be able to set the bit in the configuration. This is secondary because we have management.
Okay.
So I'd like to ship the other right away. That's the point.
So, Michael, so you really don't want to wait for us to do capabilities in any way to do 8138. What you're saying? You want to do it. We could do 8138 with capabilities is the point, right? But you don't want to do that. You want to ship it the way that it is.
I want to ship turn on the way it is, and then define how you express the capability in this draft.
So you want to control it being on or off with turn on, but you want to find out if it's available with capabilities. Okay, I can live with that.
Okay.
Which is what we do for use of REPL info, unless we want to hold use of REPL info, right?
Right. Okay. Right. So there have, in context to MOPEX, there has been very less changes. One is the final MOPEX calculation, and the other part is if MOP value is 7, and we will discard the DIO if the MOPEX is not present, if the MOP is equal to 7. Yeah, this is already clear. So 2 questions. MOPEX currently has 24 bits. Now, do we really want to use those many bits? Because as I can see, our dependency on MOPs will reduce with capabilities. So we can do with less number of bits for MOPEX. But again, I don't see much of a value there, because once we start eliding such fields, then it might not even be important to worry about the field size then. But I would like to have any opinion here. Second question is whether we should split the 2 topics, the MOPEX and CAP. The reason being, looks like capabilities might take some time to mature, and MOPEX is really a simple thing to do. We might as well ship it separately. And there is a clear difference. I mean, there is no overlap of information between, there is no overlap of thing between MOPEX and capabilities. So any views there?
I would really push that question to Alvaro, because basically it makes more sense, for the engineering for us to split. So we have one document for one thing and the other document for the other thing. But now that means both will be standard track documents to go through the ISG, and the ISG might not like it. So if MOPEX would be a very simple one, and we could flash it through.
Alvaro Tanrariti. It doesn't matter. I would prefer one document just because it's easier. I process only one time and that's it. But whatever the working group wants to do. I know there are other non-ISG, even technical considerations around having multiple RFCs. I've heard from other working groups, for example, the need to do RFPs and point at one thing or another. So if we need to split the functionality, that's perfectly fine. So whatever you guys want to do works for me.
Okay, thank you.
Good. So I would like to have 2 documents. I asked for that before. And here's I think your diagram is incorrect. And I just looked at the document and it's correct for the document. I just got 6550 and it doesn't match 6550. So if I'm not mistaken, this is a RPL option that lives in DIOs or DAOs, and they actually are in the format of a type, length, and stuff.
Oh yeah.
Right?
That should be length, right? Yeah,
okay.
That should be length.
But
yes.
the important part is that means that we can decide how big that value is, and it can be as long or as short as we like because we have a length.
Yes.
Would you like 64 bits of MOPX? Probably not. We probably should have a maximum. But the point is that if we have only 1 byte to send and we say it's an integer and it fits in 1 byte, we only have to transmit 1 byte. At the point where we have defined 256 MOPX values, we can add a 2nd byte. We just need to make sure up front that we tell people, please pay attention to the length. But lengths larger than, I think the number would be 6, because that would be 4 bytes, are probably unreasonable. So you don't need to do 64-bit arithmetic on this or whatever. Okay, so I'm pretty sure we can do that, right? Do you agree, Pascal?
Right.
Okay, so I think that solves the how many bits should we have. We have as few as we can live with.
Right. Yeah.
Yes. So I love what I just heard. Oh, damn! I wanted to say something else. Yes. Interestingly enough, we are changing the first bits in the DIO pretty much with a new MOPX value of 7. And we don't have a version for Ripple, right? So it seems to me that somehow we are packaging a number of features together, like PDAO, which are really all these capabilities. We are really making a version 2 of Ripple. And it seems to me, which is MOP equals 7.
We can formally define that. Yeah, all right.
But that really needs to say, hey, MOP equals 7 means that you're expected to at least understand, even if you don't operate on, at least understand all the other drafts, right? So if you can't operate them purely or whatever, but you're supposed to understand all those drafts. So otherwise, MOP 7 you don't understand.
Right. Yeah. Yes.
Right. So capabilities you said was 1, but I would say let's list them and call that Ripple V2.
Okay. Fair enough. Yeah, that's all. I mean, now it's not only one major update. Looks like we will have a major revamp in the document based on the discussion today. That's all. Thank you.
Thank you very much, Raul. Pascal, do you think that the operation should be a new mode of operation? What do you think?
Well, I remember there was a discussion on the mailing list about this, and that, no, it's not. I mean, I agreed with the point that was made. That was a very good email. And again, I wonder, it's Rabi, right? It's him. I really loved his arguments. I think he made perfect sense in what he said, and I kind of bought everything. So no, it's not a new mode. You will have a main DODAG which will operate in the normal mode. You will have the capability to projected routes, and you will install them. But it's the peer route itself, it is on type. I mean, so it's not like a MOP. The MOP is the global DODAG. And since we don't use DIO to build the PDAO route, you don't have anything to express a separate MOP. But the big DAG is like Robbie said, it's what it is. We don't need a new MOP for that. So if there is still text in PDAO draft, I need to remove it. I think there's none, but if there is, I need to clean it up. I mean, if people agree, right? I do agree with Robbie. Raul?
Yes.
Okay. Thank you very much. Additional comments? Who is willing to review this draft? Thank you. Yeah. Raul, you're going to split both? Okay. Thank you. So yeah, and we are going to send the comments, the questions that we raised today. So tomorrow, yes.
Can we split it quickly and adopt the MOP X quickly?
Today we can adopt start the adoption tomorrow tomorrow.
Yeah. I think that there's not urgency. I think that we've discussed it to death, and we should just go, right?
Yeah. Additional comments, questions? Okay, so we meet tomorrow then. Thank you very much for your participation. Please sign the blue sheets. Yeah, and the agenda for tomorrow. Okay. This is tomorrow, 10. Yeah. We need the reviews for unaware leave, so please, that will be very nice if you can review that draft. Thank you very much.
There's no social event.
No, there's no.
No social event, no
And the
sleep,
restaurants are
nothing.
overrated anyway.
Because all of you are jet lagged.
Okay. Well, now as well that we are more people, we want to thank Peter again and welcome San Dominic. Thank you very much.